All right, you guys, today we're taking on inscribed angles and arcs. So first, just a reminder of what makes an angle a central angle. So the vertex has to be the center of the circle. So here's the center of my circle. I'm going to draw in a ray that looks like so, and then another ray that looks like so. So if this is the center of my circle, right here is my central angle. And then from here to here would be my intercepted arc. So again, a central angle, the vertex is the center of the circle. And the relationship is that the central angle measure will be equal to the measure of its intercepted arc. Okay, the next angle that we talked about was an inscribed angle. And when it's an inscribed angle, the vertex is somewhere on the circle, like so. Let me draw a ray here, and then a ray here. So the inscribed angle would be this angle right here. And then from here to here would be its intercepted arc. So again, the way to identify that it's an inscribed angle is knowing that the vertex is on the circle. Okay, and the relationship here is that your angle will always be 1/2 the measure of its intercepted arc. Okay, you could also think that the intercepted arc would be double the angle measure as well. Okay, but I want you to understand why this new relationship works. The central angle is pretty intuitive, but the inscribed angle, I want to help you visualize why it works. So off to the side, I want you to draw another circle. To the best of your ability, not so easy. So there's my circle, and I'm going to draw in a central angle of about 80 degrees, so about like that. There's my 80 degree central angle. Let me mark it as 80 degrees right here. So that's my central angle, so I know that the intercepted arc will be the same. So that would be 80 degrees right here as well. Okay, and then what I'm going to do is I'm going to extend this pathway, that radius, and make it a full diameter like so, and put a dot right here on my circle. And I'm going to draw another ray that has the same point of intersection right here as my central angle. So what I have now is I have the center of my circle. Here I have a radius, and here I have a radius. So I can give a tick mark here and here to show that those two segments have to be congruent. So now I have an isosceles triangle. I know that if this is 80, the supplement would be 100 because they form a linear pair. They have to add to 180. These two base angles of my isosceles triangle, they have to be the same. So I have to split that remaining 80 degrees into two parts, and I get 40 degrees here, and I get 40 degrees here. So again, I'm just trying to illustrate for you how if this is a central angle, it will match with its intercepted arc. But the inscribed angle will be 1/2 of its intercepted arc. 40 is 1/2 of 80, or the intercepted arc is double the inscribed angle, right? 80 is 2 times 40. So now a few examples. So here I'm saying find the measure of each arc or angle in circle O. And that's important because if I call it circle O, that means that O is the center of the circle. Okay. So first up, in looking at the first one, I can see that, well, that's the center of the circle. So this would have to be 108 degrees. The central angle will be the same as its intercepted arc. So then what about, if this is the minor arc of 108, what would be the major arc from here to here? Well, that major arc, I'd have to do 360 minus 108. And that's going to get me 252 degrees for this major arc. So measure of angle FOR is 108 degrees. And the measure of the major arc, FKR, so here all the way over to here, is 252 degrees. Okay, next up, here O is the center of the circle, so here is a diameter. That information tells me then that this has to be a semicircle. So right here would be 180 degrees. Semicircle, half the circle, always 180. This would be another semicircle from here to here. So together they have to sum to 180 also. So if I take 180 and I subtract 126, I now have 54 degrees right here. And since I want this angle at some point, right, I need to do half of the 54 because it's an inscribed angle. Vertex is on the circle. So right here will be 27 degrees. So the measure of FM right here, well, that was 54 degrees. And the measure of angle FRM right here is 27 degrees. So with a lot of these, all I'm doing is I'm trying to fill out as much information as I possibly can before answering the question posed. Okay, next up here, I see an inscribed angle because vertex is on the circle. And I see these congruent chords. And I have to remember that the arcs of congruent chords are also going to be congruent. The same portion of the circle is being cut off. So whatever this measure is, this will be the same. So what I have to do first is I'm taking the 360 total around the circle, deducting 160. So I'm left with 200 degrees. So 360 minus 160. I'm left with 200 degrees, and I have to split it two ways. So I get 100 degrees right here and 100 degrees right here. So again, my arcs of congruent chords are going to also be congruent. So now also I can get to this angle, inscribed angle, half of the 160. Here is 80 degrees right here. So the measure of PAN is 80 degrees. Measure of minor arc AN, so AN right here is 100. Okay, next up, here I'm seeing that I have a regular pentagon that's inscribed inside of my circle. I could also visualize that as I have 5 congruent chords. So 2 ways to really picture it. So if I first picture it as, well, I have these 5 congruent chords, so I know that these 5 arcs will all be the same. Well, then I can take the 360 and split it 5 ways, getting 72 degrees. So each of these arcs would be 72 degrees. Let me label all of those parts. Okay, and then if I'm trying to get to each of those interior angles, well, I know that it's an interior angle for a regular pentagon. So I can go back to this n minus 2 times 180 divided by n formula. So if I plug in a 5 for the n, I get 540 as my total sum of all the interior angles. I have to split it 5 ways. So I get 108 degrees. So each of these interior angles is 108 degrees. And then I just have to answer my questions. So AK, minor arc AK, so from here to here, if I add up those 272s, I get 144 degrees. And the measure of PSK, so PSK, angle PSK, PSK right there, has to be 108 degrees. All right, next page, either flip over or turn to the separate sheet. Let me just get myself situated and drag this part down. Okay, so we're moving on to inscribed quadrilaterals. So I'm just going to draw a 4-sided figure inside of my circle. So it doesn't matter how you do it. I'm going to do it like this. Okay. So I have an inscribed quadrilateral, 4-sided figure. I'm going to label the angles as A, B, C, and D. Okay, so first thing to note is that, well, those four angles together, they have to add to 360. We know that's true for any quadrilateral. So A plus B plus C plus D gotta be 360 degrees total. Okay, the other thing to notice, let me just draw a second one off to the side and point something out to you. Let me relabel. That's my B. Here's my A. Here's my C. And here's my D. Let's say that I focus on angle A for a moment. So here's angle A. And if I extend here the rays of the angle like so, I can see that this would be its intercepted arc from here to here. I don't know what it is, but I know that the angle will be half of its intercepted arc. So if I look at C that's in the opposite position right here, and again, here's the vertex of the inscribed angle, and I trace out the rays pathway to here and to here, I can see that the intercepted arc would be from here to here. So again, I may not know what its specific measure is, but I do know that it has to be half of its intercepted arc. And since when I look at A and C, their intercepted arcs take up the whole circle, then it's safe to say that the sum of A and C will be half of the whole circle, which would be 360. So any inscribed angles that are in opposite positions, they end up being supplementary. Let me write that. So inscribed angles in opposite positions are supplementary. They have to add up to 180, right? Half of the 360 total. So I know that then A plus C would have to add up to 180, and B plus D would do the exact same thing. Okay, next we have the right angle corollary. So here, let me start by just drawing in a diameter. So here's a diameter of my circle. So here's the center of it. Remember that a diameter is the longest chord that we can possibly draw for any circle. So here I know that this would be 180 degrees, right? That's just a semicircle. That's the measure of the arc that's exactly half the circle. So if I draw in an inscribed angle, I'll put the vertex here, where it connects through the endpoints of a diameter here and here, I know that that inscribed angle will have to be 90 degrees, right? Because my inscribed angle has a semicircle as its intercepted arc. So it creates that right angle, that 90-degree angle right there. So let me summarize that. So if an inscribed angle has a semicircle as its intercepted arc, then it's going to be a right angle. So 90 degrees. Okay, and then the last corollary, let me start by drawing an inscribed angle. Okay, a corollary, like I've said before, it's really just an extension of a theorem or an idea. So here is an inscribed angle. This would be its intercepted arc right here. This is the inscribed angle like that. Let's say that I put a vertex right about here, and I draw another inscribed angle that has the same intercepted arc, like that. Same intercepted arc. Well, I know that the angles would both have to be half of that intercepted arc. So I may not know what their measures are, but I know how they're related. So I know that if angles share the same intercepted arc, well, then they have to be congruent angles, like so. So here, if angles share the same intercepted arc, then they are going to be congruent. Okay, and now a few more examples. So find the measure of each angle or arc in circle O. Let me just slide it up to here. So here, if I start off by looking at that 94 arc. So right here, vertex on the circle, this is an inscribed angle, has to be half of 94. So that gives me a 47-degree measure here. This angle has the same intercepted arc, so also 47 degrees. Okay, if I move over here to where L is, this right here, right, for this angle right here, its intercepted arc is 76. So half of 76 is 38. So I have a 38-degree measure here. Where S is right here, that inscribed angle, it has the same intercepted arc, so also 38 degrees right here. Okay, and then if I fill in the missing angles of the triangle, here, these two are going to sum to 85 degrees. So this angle right here has to be 95 degrees. And then its vertical angle has to be the same. So also 95 degrees right here. Okay, and then if I fill in the supplements for the linear pairs, I get 85 here and I get 85 here. Okay, there's a new relationship that's going to come at us tomorrow. So I just want to point that out. So if I look at where here is A, if I look at that 85 and I look at these two intercepted arcs, so I see 94 and 76. Here my vertex of this angle right here, it's in the interior of the circle, right? It's not the center, but it's somewhere inside of my circle. So if I think about, well, how is 85 related to these two numbers? Well, I can see that 85 is really the average of 94 plus 76. That's a new relationship that we'll address tomorrow. All right, so the measure of angle NSA right there is 38 degrees. Okay, SIL right here is 47 degrees. And then SAN right here is 95 degrees. Okay, next up, so in this picture here, I am given this angle is 110. So I know that right here, these angles are opposite. So this would have to be 70 degrees. Okay, I know that when I have an inscribed quadrilateral, the angles in opposite positions, they are supplementary. They're going to add to 180. So if this is 85 right here, this guy, got to be 95. Boom, just like that. So angle R has a measure of 70. Angle K has a measure of 95. Okay, and then I'm asking for the measure of ARK. So I'm asking for this arc right there. So it has to be a major arc. So if I think about, well, how do I get there? Well, if I look at where P is, here, this is its intercepted arc, and then this right here is the inscribed angle. So I just have to double it, and I get 220 for that major arc. All right, two more and then we're done. So here, find the measure of each angle or arc. So my first instinct, since I look at my circle, I see that most of those arcs are filled out except for this one right here. So I know that if I take 360 and I subtract 72, 44, 86, and 60, what's left over would be this portion right here, and that's 98 degrees. Okay, and then I'm looking at a bunch of inscribed angles. So right here where this angle is, vertex on the circle, this angle will be half of 44, so 22 degrees. Okay, right here, half of 72 gets me 36 degrees. Okay, right here also half of 72, I get 36 degrees. Okay, going over to here, Here is the intercepted arc with this vertex on the circle where O is. So half of 60 gets me 30. And over here, same thing, half of 60 gets me 30. Okay, and then building off my knowledge of triangles, I know that this triangle has to add to 180. So this is 66 degrees, so I'm missing 114 to make it whole, add to the full 180. Its vertical angle here, 114 also. And then the supplementary linear pairs would get me 66 here and here. So SEC right here is 22 degrees. Okay, OR, this minor arc is 98 degrees. That two-letter notation means minor arc. Okay, ECR, so ECR here is 30 degrees. ORC, ORC right here is 36 degrees. And then CDO, so CDO here is 66 degrees. And remember what I've just alluded to before in an earlier problem. Here I see that that vertex is somewhere inside of the circle. It's not exactly the center, it's somewhere inside. I know really that's going to be the average of these two numbers here and here. So the average of 72 and 60 is going to get me 66, and that's where we're headed tomorrow. All right, last problem. So find the measure of each angle or arc, and then XZ is a diameter. So if this is a diameter, it's making sure we note that. We know that that splits the circle into two semicircles. So I know then that if this is 64, this has to add to 180, then this is 116. If I build off the 24, this is an inscribed angle, I double it to get to its intercepted arc. So right there is 48. And then again, this is a semicircle. So this has to add to 180. So this whole part has to be 132. Okay, so I filled in all of my missing arcs. Now the angles. So this angle would have to be half of 116. So I get 58. This angle right here, half of the 64, we get 32. This angle right here, half of 132, I'm going to get 66. This angle, half of 116, so 58. This angle, half of 48, so 24. This angle, half of 132, so 66. Okay, and then filling out all of the angles in here based on a triangle. So for example, this one right here has to add to 180. So 66 and 32 are going to get me 98. So this angle must be 82. And so would be its vertical angle. And then the supplementary linear pairs, I got 98 and 98. Okay, so now the measure of XYZ, so XYZ. So if I add those two up, I see that that's 90 degrees. Okay, YZ right here, that minor arc is 132. Okay, YWZ angle is 66 degrees. ZWY, so ZWY, well, that's actually the same angle, so also going to be 66 degrees, right? These are the same angle. Okay, and then XAY right there is 82 degrees. I love these. They're like little circle puzzles. Pretty fun. All right, that's all I got for you today. Hope you guys have a lovely rest of your day.